Before any Python program runs, before a single line of code executes, there is silence, a deep, heavy silence, a silence that feels like the world is holding its breath. Then, somewhere inside your machine, something wakes up, not loudly, not violently, but with purpose. A system comes alive. A world opens. A hidden universe begins to glow. This is where our story begins. Deep beneath the surface of your computer, beneath the apps, beneath the windows, beneath everything you touch, there exists a warehouse. Not a chaotic one, not a messy one, but a warehouse built with precision, with structure, with intention. Rows of shelves stretch into the distance, perfectly aligned, perfectly measured, perfectly ready. This warehouse is memory, the place where everything your program creates must live. Numbers, words, lists, functions, even Python's internal machinery. All of it sits on these shelves. When your program starts, it's like someone flips a giant switch. Lights ripple across the warehouse. The shelves illuminate. The system awakens. You never walk inside this warehouse. You never touch the shelves. You never move the boxes. Instead, you interact with this world through something small, something simple, something that feels almost trivial. A name, a word, a label, a variable. Most people imagine variables as containers, little boxes that hold values, a place where you put a number or a string. But Python does not work that way. A Python variable is not a container. It is a label, a tag, a name attached to an object. When you write x equals 10, you are not placing 10 inside x. You are attaching the label x to the object 10. This idea changes everything. Variables do not store objects. They reference them. They point to them. They name them. Once you understand this, Python becomes clearer, cleaner, more predictable. You stop imagining boxes. You start imagining labels. And the entire language begins to make sense. If variables are labels, then what exactly are they labeling? Objects. In Python, everything is an object. Not just numbers and strings. Not just lists and dictionaries. Everything. A function is an object. A module is an object. A class is an object. Even your code is represented internally as objects. Every object has three qualities. Identity, its unique address in memory. Type, what kind of object it is. Value, the data it holds. Think of each object as a sealed box on a shelf. The box has a barcode, a category, and something inside. When you write x equals 10, Python creates the object 10. It places it on a shelf. It gives it an identity. It marks it as an integer. Then it attaches the label x to it. Later, if you write y equals 10, Python does not create a second 10. It simply attaches another label to the same object. Two labels, one object. This is the heart of Python's memory model. Now imagine this line, y equals x. Python does not copy the value. It does not duplicate the object. It does not create anything new. It simply says, attach the label y to whatever x is pointing to. Two names, one object. This is why mutable objects behave the way they do. A equals 1, 2, 3. B equals A. Both labels point to the same list. If you modify the list through one label, A append 4, the change appears through the other label as well, because there is only one list, one shelf, one object. This is not a trick, not a bug, not a surprise. It is how Python works. Python's objects come in two species: immutable objects, numbers, strings, tuples, booleans. Once created, they cannot change. If you modify an immutable object, Python creates a new one. It places it on a new shelf and moves your label to the new object. X equals 10. X equals x plus 1. Python does not change the original 10. It creates 11 and moves the label x to the new object. The old object stays where it was. Mutable objects, lists, dictionaries, sets. These objects can change in place. Their identity stays the same. Their shelf stays the same, but their contents shift. It is the difference between replacing a book and rewriting the pages inside it. This distinction shapes how Python behaves. It affects performance. It affects debugging. It affects how data flows through your program. When you assign a variable, Python performs a simple ritual. 1. It creates the object if needed. 2. It places the object on a shelf. 3. It attaches your label to it. That's all. No copying. No duplication. No heavy work. Just labeling. This is why assignment in Python is fast. Why passing variables to functions is efficient. Why Python feels smooth and effortless. A variable is simply a name, a reference, a pointer. Assignment is the act of naming. When you reassign a variable, x equals 20, Python does not modify the old object. It does not rewrite the value. It does not update the shelf. It moves the label x to a new object, the object 20. The old object remains where it was. If no other labels point to it, it becomes unreachable, unused, forgotten. And that is when Python steps in. Inside the warehouse, there's a silent worker, a quiet figure who moves between the shelves, checking, inspecting, cleaning. This is Python's garbage collector. Its job is simple. Find objects with no labels, objects that nothing references, objects that no part of the program can reach. These objects take up space. They clutter the warehouse. They serve no purpose. So the garbage collector removes them. Automatically, efficiently, silently. You never call it. You never manage it. You never think about it. Python handles memory, so you can focus on logic. Variables are the foundation of every Python program. They are the names you give to your ideas, the handles you use to shape data, the labels that connect your logic to memory. Understanding them changes how you write code. It makes your programs clearer, more predictable, more elegant. Because once you understand the warehouse, once you understand labels, once you understand objects, you understand Python, not as a language of syntax, but as a world of memory, a warehouse of objects, a universe of names. And in that universe, variables are your guide. Every time you write a line of Python, every time you assign a variable, every time you create an object, you are shaping this hidden world. You are placing labels. You are guiding memory. You are building meaning. And now, you understand what truly happens in the quiet warehouse, inside your machine. Thanks for watching, and I'll see you in the next chapter of this digital adventure.